I didn't prepare a joke, so in lieu of a joke, first I just want to thank the organizers for putting together this conference. So I lead data science at Hinge, and in particular efforts around the recommender system. I'm here to talk to you a little bit about challenges in teaching machines about the most inscrutable human emotion, love. So first, a little bit about Hinge. So in today's world, we believe that people are so busy matching, they're not connecting. And Hinge is on a mission to change that. We're the app that's designed to be deleted. Our users have the opportunity to fill out detailed profiles, which encourage authenticity and vulnerability. And by one metric of success, 3 out of 4 first dates on Hinge lead to second dates. As you can imagine, online dating is very naturally provides some of the most interesting data science problems, as well as some unique set of challenges. So the theme of this talk is one such challenge, especially in the context of building a recommender system, and that is balancing what's good for the individual versus what's good for the collective. So in the first part of this talk, I will focus on, I will explore a situation where machine learning is really good at learning about the individual, and in doing so, ignoring what's good for the ecosystem. So first on background. Machine learning in some way is like made for personalization. And in the context of recommender systems, machine learning algorithms tend to be very effective at solving the personalized ranking problem. And if what you're making is, let's say, a TV show recommender, that's all you need, because the supply of every item is unlimited and there are no ecosystem effects. However, in online dating, there's also an optimal distribution problem. So let me explain that. First of all, the effects of receiving the same recommendations are actually not independent. So in the TV show recommender example, it doesn't really matter if you and I both got recommendations for Game of Thrones, we can both watch that. But in online dating, because people's interest and capacity to date multiple people is limited, if you and I receive the same recommendations, that does actually affect both of our user experiences. And secondly, if all we use in this online dating recommender is the output of machine learning, which is personalized ranking, then you can imagine we're in a situation that a small group of users receive all of the interest, and a very large subset of users receive no interest. And both of those extremes are bad user experiences, so we have to address that. And thirdly, to have real-life success, interest needs to be reciprocated. So what do we do at Hinge to address this? Well, we take a two-step approach. So we do use machine learning to generate personalized rankings to learn about your personal preferences. And then we apply techniques from economics and operations research to the output of machine learning in order to solve the optimal distribution problem. And one example of this is Hinge's most compatible recommendation, which is powered by the Nobel Prize-winning Gale Shapley algorithm. So for some context, most compatible is the Hinge feature where we pair you up with one other user every day, and that person also only is paired up with you. So the pairings are one-to-one, and these pairings have what we call the stable matching property, and intuitively that just means theoretically no two people should have the incentive to form a new pair. And because this is like a really self-contained and actually beautiful algorithm, I'm going to take a few minutes to just demonstrate how this works. So the first step is that we divide users into 2 groups. Traditionally in the literature, these 2 groups are men and women. We do adapt this slightly at Hinge to make it work for users of all genders and orientations. And then this is the ML step. We generate, for each user, their personalized ranking of users in the other group. And now we start matching. So to start, every user in A will propose to their top choice in B. And by the way, by propose, I mean that in the algorithmic sense. I don't mean like these proposals are happening in real life, although I'm sure that would be spectacular. So, Alex will propose to Finn, Blake will propose to Haley, and so on. And then each user from B will accept the proposer that they prefer the most. So Alice and Haley receive only 1 proposals, so those are the proposals that they will accept. Finn, let me go back. Finn received 2 proposals from Dana and Alex, so Finn will accept the proposal from Dana because Finn prefers Dana over Alex. Now, in the next iteration, every unpaired user from A will propose to their second most preferred choice. So in this case, Alex will propose to Alice, say that 5 times fast. And that person in turn will accept if they're either unpaired or if they prefer the new proposer to their current match. So because Alice does prefer Alex over Casey, Alice will leave Casey, although Casey would never know, and accept the proposal from Alex. So this process will continue until every user is paired up. And in this simple example, all there's left to do is for Casey to propose to their second choice, Glenn, and now everyone is paired up. So if we take a moment to look at this, in this simple example, almost every user got their first or second choice. So in some sense, this algorithm is able to achieve a Pareto optimum between what individuals want and what's good for the ecosystem. All right, so in the second part of this talk, I want to discuss another variation on the theme of individual versus collective, and that is the topic of bias. So in a machine learning system, often bias arises because algorithms learn too much about what's popular and not enough about what individuals want. So kind of like the opposite of the previous problem when algorithms overemphasize the individual. And so some background. So in recommender systems, almost every recommender system has selection bias. And the reason for that is data used to train and validate models is very unlikely to be representative of all possible user-item interactions. And again, if we think about like, the TV show recommendation, if all I've seen in the past is fantasy shows, then over time, a recommender system will get very good at learning my preferences within the fantasy genre and be able to rank my relative preference within that genre. But it may never know that I also like comedies because I never had the opportunity to watch comedies. And one very particular type of selection bias is popularity bias, which, as its name suggests, is when recommender systems create a feedback loop that reinforces popularity. So on the one hand, we have positive feedback increasing the likelihood of being recommended, but also being recommended increases the likelihood of positive feedback. So individuals with more kind of idiosyncratic preferences and items that could potentially satisfy these individuals may never be surfaced unless these items are also popular at the population level. So what do we do to manage population bias? As obvious as, or popularity bias, as obvious as this sounds, the first thing you must do is to understand the product. And in particular, does the way that users engage with the product and the way data is captured amplify the bias? So if you're building this TV show recommender and the only ratings you're using to train your models are from ratings that users are from TV shows that users actually watched, then you could be disproportionately capturing positive feedback over negative feedback. Now, at Hinge, the way our app works is that you must rate every user that we show you. So this issue isn't quite amplified. But we want to do something to actively counter the possibility of bias. And what we do is we intentionally introduce what's called exploration slots. So we take the output of machine learning and our optimal distribution algorithms. We actually replace some of those recommendations that are carefully curated with lower ranked recommendations. So in mathematical terms, you can think of this as randomness. In practical terms, you can think of this as diversity. And by making that very intentional choice between conversion and diversity, we're able to continuously learn our users' preferences and address and even celebrate more idiosyncratic preferences and attributes instead of ignoring them. Having said that, bias is an extremely complicated topic. At Hinge, we don't pretend to have all the answers. We're aware that we may not even know all of the questions. But these are some questions that we do think about. So how do we even define bias and fairness? In the context of online dating, does fair mean that all of our users need to have, their recommendations need to follow the same distribution with respect to particular attributes? Or does it mean something else? And then if users themselves have biased preferences, how do we reconcile learning those preferences, which is what machine learning is supposed to do, with making unbiased recommendations? And is making unbiased recommendations our social responsibility? And to kind of like elaborate why this is a really complicated question, typically we associate preferences for or against certain attributes, such as race and ethnicity, with prejudice. But a lot of our minority users actually do prefer to date someone within their race or religion because of shared life experiences. So if we're able to help them do that, is that a good thing? So it's a very complex question. We don't have answers for this, but it's just something that we're cognizant of and that we're having continuous conversations about. And then finally, just a note on kind of this topic of responsible AI. I really want to emphasize that all machine learning and artificial intelligence algorithms ultimately are defined by human input. So what that means is business problems are formalized as optimization problems. So what your models are optimizing for ultimately are defined and decided by the humans who are making these models. And quality and fairness of algorithms are functions of how we define these concepts, as well as how we carry the data that these models are based on. So the previous speaker told you not to fear AI. I'm telling you to fear AI, but the reason isn't what Hollywood tells you. It's not in the near future. I don't worry about AI being smarter than humans. I worry about AI not being smarter than humans and therefore inheriting the flaws of the world that humans have made. And this is not a problem that data scientists and machine learning researchers can solve alone. And instead, identifying potential sources of bias and having continuous discourse about addressing them is a responsibility shared by everyone involved in making a product. Thank you.